Hi, in this video we'll go over network programming in Java. So basically we'll look at how you can create a client program and a server program and enable communication between those two programs over TCP/IP. So basically what this involves is socket programming. So you're going to be creating a server socket and a client socket. So that opens up a communication channel between the two over the network, and then and once that communication channel is set up, then it's basically like I/O operations, wherein you write to the I/O object and then read from it. So that's how it would work. So here's the server, which is the host, and always it's the server program that needs to be started first. Typically the purpose of a server program is it is serving some purpose. So it's listening for connections and waiting for clients to connect to it, and so that this server can then provide the service that it provides. So the server program is the one that has to be started first. So what that means is, so in the server program we create a server socket object. So we create a server socket object and provide it a port number. So in this case we're using say port 8000. So basically it's going to listen for connections on that port number. So the client that needs to connect to the server needs to be aware of that port number and the IP address of the server to be able to connect to it. And then so once the server object is created, the next thing is it's basically waiting for connections from the client, and the moment it receives a connection, the accept method will accept that connection, and then the channel for communication gets established. Now on the client side, what happens is we create a client socket, and then in order to create the socket object, to the constructor we have to pass the host information, which is the IP address, and then the port number. So like I said, the client needs to be aware of this information to be able to connect to the server. And then basically once it has this, it creates a socket object, and then that sends a request to the server. The moment the server accepts the request, the communication channel is set up, and through I/O stream they basically can pass data to each other. So that's the overview of how the client-server communication works. So the data transmission through sockets, the way it happens is we use the data input stream and data output stream objects. So basically in the server program we create the input and output stream objects. They're called in and out in this example. And then we create our server and then the socket object to accept client connections. So the purpose of this socket object is, for each client connection that's received, there's a new socket object that gets created. So here in the first step, you see we're creating our server object with the port number. Then basically the server is just waiting for clients to connect. So it's listening for any connections. The moment it gets a connection, it accepts the connection and creates a socket. So that's representing the client now. And then it also has to create an input data stream and output data stream object, because it basically those streams are going to be used to read data, and to read data that the client is sending, and to write data to the client. So that's the purpose of the in and out objects. And when these input output streams are created, we have to specify socket, because with which client are we trying to set up this communication channel. That information is encapsulated in the socket object, so that's passed as an input. So you basically use the method socket.getInputStream to initialize the input stream, and socket.getOutputStream to initialize the output stream. Now once we have that, then the communication is basically as simple as writing out, so println to the input stream, and then over here from the input stream we are reading a value, a double value. So there's multiple on the input streams, as you may already know, there are multiple methods. Can read a double value, or read an integer, or read a character, or read a string. So there's separate methods for each of these. So in this case, we want to read a double value, so it's basically going to wait till a double value is placed on that input stream, and once it is, it gets read, and this statement is just printing it out to the console. Then the server might have to do some computation on the input values that it just read. It does that computation, and then it writes the output to the output stream so that the client receives it. And that's what you see over here in the last line. We use the output stream and now use the write methods. So instead of the read methods, now we're going to use the write methods to push that value to the output stream. So we're going to write a double value, and we're basically passing whatever that number is, and that will push the value to the communication channel and to the client. So that's what happens on the server side. Now, in a similar manner on the client side, the client needs to know the port number and the IP address of the server that it's connecting with. Now, in the examples that I show, instead of an IP address, I'm just going to use localhost, which means both server and client are on the same computer. So in that case, we can just say localhost for the host information. Now on the client side also, it's going to need an input and output stream of its own. So that's where it's going to read its values from and write its values to. And then it's going to need a socket object. So the socket object is created with the host information and the port number. So that's when a request gets sent to the client, to the server. And then once the server accepts that and sets up its I/O streams, and that's when the communication begins. So on this side, the client also sets up its input and output streams. So the same thing, it has to use the socket and socket.get input and get output stream. Once it has that, basically it can send a number by using the write double method onto the stream. So that sends the value to the other side, to the server side. And then when the server writes anything onto the communication channel, that gets sent to the client, and then the client can read it from the input stream. So that's how the communication works. The key things over here are using the data input and output streams and setting those up so that the I/O communication can happen. So we'll look at an example, a client-server example, wherein the purpose of the server would be to receive data from the client and compute area. So basically the server has the ability to compute say the area of a circle. So the client sends the radius value to the server reads it from the I/O stream, and then does the computation, computes the area, and then writes the area back onto the I/O stream so that the client can receive it and read it. So we'll set up the I'll show you how the communication is set up, and then how the values are passed between the two programs. So let's take a look at the code. So here's the server program. Now it uses Swing for a simple UI, and I'll show you how the UI looks. But basically in the main method, all we're saying is, we're creating what's called a server class. So it extends JFrame. So in the constructor of server, we're first setting up some of the UI, the basic UI, and then inside the try block, now exception handling has to be provided in network programming, because whenever we create sockets, those are they throw checked exceptions, so a try catch block has to be provided. So in this case, and so if you're not familiar with exception handling yet, I would say follow these examples and provide the try catch blocks as shown in the example, but later in an exception handling video we'll go over the details of exception handling. So over here you see that we're creating a server socket with the port number 8000. You could use other ports as well that are available on your computer. There are some that are reserved for certain purposes, so you cannot use them, but you can use any of the freely available ones, which are usually the 8000 and higher. So in this case, once the server is created, we basically print out a message to the UI saying that the server was started at such and such date and time. Next, the server is basically waiting and listening for connection requests. The moment it gets a connection request, it accepts it using the accept method. So until then, the execution will stop at this statement and wait for any connections to come in. Once the connection is accepted, then it creates a socket object for that client, and then we create the input and output stream objects. So that's basically by invoking the get input stream on and the get output stream on the socket object. Now once we have that, so the communication is set, the communication channel is set. So in this case, so in an infinite loop, basically the server is going to read radius value that the client sends, and then it's going to compute the area and then send the area back to the client. So here from the input stream, it's reading a double value, which is the radius. So if the client has not sent the radius value, the execution will just wait at this statement until it receives that value. So once the radius is received, it will compute the area, and then it writes back the area using the write double on the output stream. And then it's also printing out some useful messages about what it received from the client and the area that was found. So let me show you the client program as well, and then I'll show you how this looks when it's executed. So on in the client program, which is a separate program, this is also written to extend JFrame. So there's a simple UI, and then in the constructor, the UI the frame is set up with all of the necessary properties. And then in the try block, you see this is where the network programming part starts. We're creating a socket object. We want to connect with localhost, so we're basically connecting on the same computer via port 8000. Now there are other ways in which we could connect. If there is an IP address, you would typically specify the IP address in quotes, or if there is a URL, a server name, then you can specify that server name. But in this case, we're going to use localhost, so I can run both the client and server on the same computer. Next, once the socket object is created, again here as well, we need to specify our input and output streams. So that's what we're doing through this from server and to server. Next, what's going to happen is we have some UI elements, and when a value in a text field changes, that's when we want that value, we want to read that value from the text field and send it through our IO stream to the server. So that's what's happening here in the action performed method. Again, this is event-driven programming, and details of event-driven programming are in a separate video that you can refer to. So, but basically the idea is that this is a text field listener that's registered with the text field object, and any changes to the text field, any changes in the value will basically trigger this method, and then the action performed method is what gets executed on that event. So in here we are basically reading the radius value from the text field, and it's being parsed as a double, and some trimming is being done to remove any spaces because it's probably entered as a textual value. Once we have the radius, we basically write it onto the servers, onto the IO streams, so that it is sent to the server. And then we're basically waiting to receive an answer from the server. So that's what happens over here in this statement. Until it receives a value back from the server, the execution stops at this point, and once the value is received, it's read and stored in the area field, and then it's the area is written onto its UI. So that's how the client side works. So basically, when we want to run these programs, you have to compile both the client program as well as the server program, and then run them. So like I said before, we have to run the server program first. So that's what I'm doing. I'm running the server program. So it has started. As you can see, there is a message that says server started at, and it shows the time. That's just informational message. And now at this point, the server program is waiting for any client connections to come in. So it's just listening to the port 8000. So through another command line window, I'm going to now run the client program. So here's my interface for the client program. All it has is an enter radius text field. So I'm going to enter a number into the text field. So now that text field value gets read, and then it's now going to be passed on to the server. So I'm going to hit enter. So the radius 5 was sent to the server. As you can see here, it says radius received from the client. And then it calculates the area as 78.53, and then that's passed back to the client, and so the client is able to print it out over here and say that the area was 78.53 that it received. Now we can continue because the server is sitting in an infinite loop and the connection is still open. We can enter other values. Say I'm going to enter the value 25 and send that. So 25 gets sent, the area is computed, and it's sent back to the client, and so on. So this process will continue until we close down these programs. Say I send another radius, we'll compute the area and send it back. And then when I close the client, that's when the program is closed. Now the server can still wait and listen for other connections, or we can just close it. So that's how the communication between client and server program happens. So basically in this example, what happened was on the the execution started on the client side when it basically wrote a radius onto the data output stream. From there it gets to the socket output stream, and from there it goes to the socket, and through the network it gets to the server side, and it gets through the server socket, from there to this to the get input stream, to the data input stream, and that's where the server reads it. So that's how the data is passed from the client to the server. And then once the server has computed the area, what it does is it pushes the area to the data output stream. From there it gets to the socket's output stream, to the socket, and then through the network to the socket of the client, and then to the input stream of the client, and then to the data input stream of the client, and that's where the client reads the area from. So that's how the communication is happening. Now the inet address class is a useful class that we should be familiar with. It's a way to find out the client's host name and IP address. So when the server receives connection and creates a socket object, it can basically determine the IP address and the host name of the client using this inet address class. So on the socket object, there is a get inet address method. So that can be invoked to create an inet address object. And once we have this object, then it provides a number of different useful properties, get host name, get host address being the most useful ones. Now the previous example that we saw serves one client at a time, but there is a way to write these server programs to serve multiple clients at the same time, and that's where multi-threading comes into picture, and we'll have to create thread objects to delegate each client to one thread. So the way the multi-threading works is basically the server, once it's created, it basically sits in an infinite loop waiting for connections. So here's our infinite, we have the while true loop, which is basically an infinite loop. It never stops until the program is closed or the server is closed. So at this line, it's waiting for a connection. The moment a new client connection is received, it invokes the accept method and accepts it. And then at that point a task object is created to handle this particular client. So which means is the handle task class has to describe what needs to be done, what's the task to be done with this client connection that we received. Now once we have the task object, we create a new thread and pass the task object to it and start the thread. So once the thread is started, we have delegated it, it's going to independently do its work, and then the server program, which is kind of the main thread, the main program is also a thread in itself. So that's the main thread is going to continue running, and it passed the first client off to a separate thread. So in the main thread, what's going to happen is it's going to go back here and continue waiting for the next client connection to come in. Whenever the next client connection comes in, it does the same thing, creates a task object, a thread object, starts it, so it delegates it off to another thread and goes back to waiting for connections. So that's how a server that serves multiple clients is designed. It's basically sitting in this kind of a infinite loop, waiting for connections and delegating the work to threads. So we'll look at this example of a multi-thread server, and we'll see how that works. But basically what's happening is when client 1 connection is received, the communication channel is set up, and then the socket is created and it's passed off to a separate client. And the same thing happens for all of the end connections that it receives. So let's take a look at the multi-thread server example. So here's the example wherein again, like I said previously, it extends JFrame. So in the constructor, there's UI specific statements, and then in the try block, we're creating the server socket, listening to the port 8000, and we print out a message to the text area saying that the server has started. In this case, we're keeping track of the number of clients as well. So the client number is initially set to 1. So in the infinite loop, it's the server program is basically waiting for connection requests. The moment it receives a request, it creates the socket object, and then it prints out a message saying that the first client, or whichever, the client number, and then the date at which a thread was started for the client. Now here you also see the use of inet address. We're using the inet address object, and we're retrieving that from socket.get inet address in order to retrieve the host name and host address, so the IP address of the client that we received the connection from. Now once some of those basic operations are done, our next step is to create a task object, and then we create a new thread, and to this new thread we're passing the task object as the input, and we're starting the new thread. Once a new thread is started, this server program is done because the thread is going to handle the client. The client number is incremented, and then it goes back to listening for new connection requests. So that's how the multi-threaded server works. Now the task class, we had handle a client task class. Let's see what it does. It basically, it has to implement the interface runnable. So in here, it's the socket object that it receives, that is stored as the data field. So in the constructor, the socket object is passed to the constructor, and that sets the data field. In the run method, so that's where all of the operations happen. In the run method, it's basically going to create the input stream and output stream for this specific socket, and then it's going to serve the client. Basically, it's going to read the radius, compute the area, and then write the area back to the client, and it's going to continue doing this as long as the client needs the service. So that's the reason you see that it's again sitting in an infinite loop. Whenever the client closes down, this thread will shut down as well. So that's how the multi-threaded server works. We can run it and see how it looks. So basically, I'm going to this time run the multi-threaded server. So there's the server has started, and then in another window I'm going to run the client program, and the client program, there's no changes to it. It still remains the same, because all the client is doing is connecting to a server and setting up the communication to pass the radius and read the area. So the client program hasn't changed. So I run the client program. So here's my first client program, and what that does is, so you see the message that it has started a thread for client 1, and it shows the client's host name and IP address. And then in here, if I enter enter a radius, it's basically printing out the radius and the area that was found. Now, while this thread is running, I can start another client. I can make another client connection. Okay, so now that started up client 2, as you can see. So here's my first client over here, and then here's the second client. And then we also see on the server there's messages that a thread for client 2 was started, and the host name and IP address of the second client is being shown here. Now independently I can enter the radius in here, and then it still does the computation for me. So basically now you see that both clients are communicating with this server and getting their responses. But what's happening on the server side is that there are 2 separate threads. Actually now there are 3 threads. One is the main thread, which is the main server program, and then there are 2 individual threads to handle these 2 clients, and then the main thread is now continuing to listen and wait for any other connections to come in. So that's how that's how multi-threading is useful in these multi-threaded server programs. The last thing I wanted to mention is that just like we use the data input and output streams because we're passing data that's of primitive data types, but then if we need to pass objects, that's still fine. Like say, for example, if you have a student class with multiple data fields such as name, SSN, and some other information about the student like the grade and their major and such, and then say we want to pass the student object between the server and client, that can be done. We have to use the object input and object output stream, but everything else remains the same. So instead of data input and data output stream, we use the object input and object output stream, and we're able to pass the whole student object across the network. So what happens internally is now what's important is that the student class must be a serializable class. So it must be marked as serializable so that the outputs from the student class can be sent in a sequential manner. But everything else remains the same. So basically on the client side, the student object is created, and then the student object is written to the output stream, and from there it's passed to the socket, and through the network it's passed to the server, and the server reads the object from the input stream, from the object input stream, and has the student object that it can manipulate. So in the samples folder, there's examples of a student server and a student client. So you can take a look at that to understand how this works. So let me quickly show you the student class that has to be serializable, and I'll show you how it's marked. So here's the student class. Basically any objects that need to be passed in this manner over the network, they must implement the serializable interface. So that and then what that means is basically all of these data fields, name, street, city, state, and zip, can now be passed in a serial manner over the network to the server or the client. So this is an important step for those objects that need to be passed across the network. So that's all I have in network programming using Java. Please feel free to use these samples that are provided in the samples folder and execute them, and let me know if you have questions. Thank you.